just a few moments as the last few people start to connect. So thank you everyone, great to have you here, really appreciate you taking the time. The session today is about security best practices on AWS. My name's Simon Alicia and I'm Principal Solution Architect here at AWS, located in Australia in my particular case. All the lines are muted, so hopefully we should have a nice quiet audio and you can hear me well enough. You can of course ask questions at any time in the question box to your right. We'll answer as many of them as we can at the end of the session, and all the questions will be answered via email as well. So if you have a question, please do ask it in the question box. We'd love to hear what you're thinking about. So our agenda for today, we'll be covering a little bit about the shared responsibility model and how to take advantage of this model. If you're not familiar with this model, you shortly will be. Then we'll move on to looking at some of the AWS security features that are available to you and how you can use them. We'll also talk about the security around AWS's own infrastructure and how you gain benefit from that security posture. And then, of course, we'll talk about what your responsibilities are in terms of having a correct security posture for your organization. So in the cloud, security is a shared responsibility. What does this mean? This means that there are three key elements that we need to focus on. The first one is infrastructure security. And this concerns the infrastructure upon which the services are built. So these are the data centers, the management of those data centers, day-to-day operations, the networks, etc. And that really is a question of how does AWS secure the infrastructure that we provide to you. The second element is that of services security. So these are tools, capabilities, and the services themselves that can provide security capabilities to you, that you can weave into your application, that you can use from a management perspective, and also the architecture of the services themselves that provide a secure framework in which to operate. And the third element is, of course, application security. And this is around how you can make your application secure and what your responsibility is to do that. So let's look at how we leverage our shared security model. Firstly, you need to understand your customer and form the correct security stance. Now, what does this mean? This means that there are a number of different audiences or different contexts in which you would discuss security. So if you're looking at an external audience, so maybe consumers of your own service, you may want to show them certifications that you've obtained. You may want to share details about your security processes, or you may even have customers who request penetration testing be done for your service to prove that it is secure. This is a very common scenario. From an internal standpoint, you'll have the requirement to prove that your architecture is secure, perhaps your own internal security group. You'll have a desire to use some sort of tiered security access using things like information access management tools. You'll need some sort of administrative control, etc. So these are things that are used inside the organization. And if you work in some sort of a regulated environment, you'll have a regulated audience. And these are the regulators that would like to see what you're doing in terms of your security posture. What are your certifications? What are the practices and procedures that you follow? Early in your adoption cycle. There is no fear here because the AWS platform meets very high standards, including PCI credit card compliance, ISO 27001, and SOC 1 compliance. We'll speak more about that shortly. But it's always a great idea to sit down with your security team, your internal security team, early and often. Security teams really dislike being brought into a project at the end of the project when the decisions have been made, everything's locked down, and then they have to make this sort of yay or nay decision. What they much prefer is to be part of the dialogue. And certainly in my experience, the earlier that we've had a dialogue with the security team, the more comfortable they feel about the solution, the more they feel they can contribute to approaches and ideas. I've personally sat in rooms at large financial organizations where I've had 15 different security engineers pinging me with questions, and it was a really great session because they got to ask the questions they needed to know. You can derive immense value from having architecture reviews early in the deployment cycle and identifying problematic areas early on. You should also take advantage of the comprehensive materials and certifications provided by AWS. So we have a risk and compliance paper, a security processes paper, and also some new question and answer that we've done as well. So I'll be showing you some more detail about that shortly. And importantly, you need to build upon the features of AWS and implement a security by design environment. So what does this mean in terms of a shared responsibility model? Well, let's make this a lot more clear for you here. So if we look at the Amazon side and the U side, if you like, at the bottom there we have the AWS global infrastructure. We have regions, availability zones, edge locations, compute, storage, database, etc. That is the area that is taken care of by Amazon. The user side is really around client-side data, the platform, the applications, the identity and access management, the operating system, the network, the firewall, etc. There are a number of components that are controlled by the customer intentionally in the shared responsibility model. So let's talk about what side Amazon takes care of for you. There are a number of AWS features that you can leverage to make your application more secure. There's the area of tiered access, the ability to control who can access various resources in your environment. There are also the security groups, and we'll talk about that in detail. There is the virtual private cloud, and there is the capability of direct connect and virtual private networks. Identity and access management provides you with a really powerful capability to create groups and users within those groups to perform various functions in your environment. These users have individual logons to the AWS console, individual security credentials. They have specifically assigned least privileged access to do the things they need to do. This gives you the option to create really well-defined security controls and perform separation of duties, which is often required in many organizations. A simple example is you may give your network team access to being able to create and make changes to the network configuration in your virtual private cloud, whereas the developers have access to create new EC2 virtual compute instances. So you get to mix and match who has access to what. And we'll talk about how that works shortly from a policy perspective. We also have the ability to actually assign multi-factor authentication devices. Now these can be hardware devices or virtual devices that can be allocated so that you can further control who can access those API calls. That can be done through the console and also directly now at the API level. So this is a very powerful multi-factor authentication mechanism that provides an additional layer of management security. At the application layer, we also now have the concept of roles for EC2. And I'll talk about what that means for you shortly. Now I mentioned that when we defined IAM policies, these are done at the API level. And these are very granular policies. By default, nothing is allowed. So we allow things on an exception basis, which means that we can control who can access which actions, and in many cases, which resources they can perform those actions against. Because this is taking place at the API level, we can go down to the specific call. So in this particular example, you'll see we're providing this particular user access to all the functions for Elastic Beanstalk, EC2, the Elastic Load Balancer, Autoscale, CloudWatch, S3, and the simple notification service. But for example, this user would not be able to perform any functions for DynamoDB or the relational database service or any service that was not listed here. So you have complete, tight, and very granular control. The IAM roles are a function that have been provided to allow automation to be improved. So this is about assigning a specific role to EC2 instances at startup time. And it allows you to control access to what they can do in the environment from an automation perspective. And let's take a step back. Why is automation important? In an environment where we have a lot of elasticity, we'd like to have automation in place through the form of autoscale, where we can grow and shrink our fleet as desired when necessary. Obviously, when a machine spins up, it may need to perform certain actions. It may need to load code and do other types of activities. And to do that, we need to pass it a specific credential so it can go and log in and do the right things. In the past, you'd have to provide those credentials through the user data, which meant that there was at some point a point where you had to expose those credentials in some way or pass them in some visible approach. Now, with IAM roles, that is done automatically, and you don't have to do that yourself. What does this mean? This means for all of the software development kits, instead of having to embed any credentials or pass them in, a simple call, as you can see in that last bottom line of code there, will automatically pick up the correct credentials that will have the correct security settings to perform the function that is required. So in this case, this particular client or this particular role would be a DynamoDB role and would allow the system to access DynamoDB as required. It's also very important to think about your key management strategy. And there are two parts of the key management strategy. There's a key management strategy for accessing your EC2 instances. And in many cases, this will be the same as what you use today. So if you're a Linux user, you'll probably have a good SSH management tool in place. If you're a Windows user, you'll be using Active Directory in all likelihood. You can use exactly those tools in the same way on Amazon with your EC2 instances. However, also remember that there are credentials assigned and certificates assigned to each individual user in the IAM world, so those groups and users, and those should also be rotated along with good password policies as well. All of those can be set and managed through IAM. It's very important to manage your keys well and effectively to protect that security posture. There are of course many cases though when you only want temporary security credentials. This may be in a federated environment, or a really common use case are developers of handheld applications or mobile applications using Android or iOS, where they may have an application that needs to access S3 for example, and they want to provide direct access for their users. But they don't want to have specific access credentials for every user, nor do they want to bake in the access credentials into the application, because obviously that makes it impossible to rotate those credentials. With temporary security credentials, which are a part of IAM functionality and are free, you can create millions of users temporary access control. So you can do this with configurable expiration between 1 and 36 hours, and it makes it very easy to manage those security requirements on an ongoing basis for a vast audience. So let's break it down using our hotel metaphor, because this helps contextualize what these levels of security are. When you create a new AWS account, you get, in effect, the master key. This is the master account or the owner of the account, and this allows you to access who can control overall management of the account. So this is like having the key to the hotel. It's the owner of the hotel. Now, of course, within any good hotel, there will be multiple employees, and those employees will have ID cards. They'll be using those ID cards when and if they need to access various areas of the hotel that they should be accessing depending on what they're doing. And those hotel cards can be invalidated and removed as necessary. That's the equivalent of the IAM user. Then the temporary security credentials that we spoke about are equivalent to our guests visiting our hotel. They visit the hotel for a short time, they need access to a very specific part of the hotel and only for a very short period of time. And we want it to be very easy to revoke those security credentials. So we give them an easy swipey card that can be easily replaced. The next thing to consider are the security groups. Security groups are a fundamental and very important part of using the Elastic Compute Cloud, EC2. So EC2 is our ability to create virtual machines in the cloud. They can be Linux, they can be Windows, the flavor is up to you. And they provide virtual compute on demand through an infrastructure web service. Security groups are part of this offering, and what they allow you to do is to control ingress of data by port, IP address, and other security group. So this allows you to control all the data that is coming into your particular instance, and by default, these security groups are locked down to allow no data to come in. So very often we get the call to a help desk saying, I just spun up a new instance and I can't log in. And the first question we ask is, have you opened the correct port for your security group? And if the answer is no, that usually fixes the problem. The virtual private cloud also supports egress data control. And we'll talk a bit about that later, but basically this means that the same controls you have for incoming traffic, you can also apply to outgoing traffic. Now the nice thing about security groups is they are fully configurable by the user via the API, command line, or GUI. There's no need to put in change requests or have long periods of outages to make changes. These are immediately accessed changes via the API. So here's our example here of a defense in-depth model of a traditional three-tier application. We have a web tier, an application tier, and a database tier. Our security group configuration for the web tier says ports 80 and 443 are open, and they're open to the internet. Now we want that because we want customers to come to our website, and we want them to use HTTP and HTTPS. That's the only traffic that would be allowed. Pinging would not be allowed, SSHing in would not be allowed, etc., etc. At our application tier, we allow traffic from the web tier directly, and we also allow our engineering staff to SSH in through the Bastion host, and we'll talk about how that works a bit later. Finally, the application tier is the only one allowed to access the database tier. However, we have allowed the database to synchronize with another on-premises database, and we can lock that down by IP address as well. So we can say only traffic from a specific IP is allowed to interact with our database instance. All other internet ports are completely blocked. This gives us a tremendous amount of control over the traffic and over who can access what parts of the system. So you should always be locking down your security groups as much as possible. Another nice capability is the ability to instantly audit the state of your entire environment using the API in real time and at any time. So you can make this call via the command line or via the API to see what is running in your environment. We have a number of customers who do this on a regular basis, and the security teams use this effectively to avoid the old-fashioned server under the desk approach, where things are spun up and no one knows why they're there and who it belongs to and has it been secured. Nothing is opaque in this environment. You can see what is running at any time instantaneously. You can identify anomalies and you can take appropriate governance action as required. Most chief information security officers love this capability because it gives them insight into their environment that they never had before in real time with complete accuracy. Another very popular capability is that of the Virtual Private Cloud, or VPC. This is a logically isolated environment within the Amazon Web Services environment that users create. You get to choose your private IP address range, you get to configure subnets in a way that's very similar to how you would do with an on-premise infrastructure. And it allows you to extend your existing infrastructure into the Amazon cloud very effectively. As I mentioned before, it allows you to have ingress and egress network access control using both security groups and also network access control lists. You also have the ability to have elastic IP addresses, network address translation, and an internet gateway so that traffic can traverse either directly to your data center or go out to the internet to service your customers. Optionally, you can have a hardware encrypted VPN connection to your VPC so that you can control and secure the traffic traversing the network to your virtual private cloud. You can also have Direct Connect. Direct Connect allows you to have a dedicated provisioned network connection to an exchange point that is then cross-connected into the Amazon Web Services environment. The nice thing about Virtual Private Cloud is that it is all wizard-driven, very simple to set up. In fact, it takes about 2 minutes to set up your VPC. Using the VPC itself costs nothing. There is only a small charge for the time-based use of the VPN connections. There is also another option available within VPC that is quite interesting to a lot of compute customers, and this is called EC2 dedicated instances. This is where instances are launched on hardware dedicated to a single customer. So you can choose not to share your infrastructure with any other customers. You can do this for your entire environment, or you can mix and match, because obviously using dedicated instances does cost a little more. So you may choose for particular parts of your application to use dedicated instances, and for others to use non-dedicated instances. Let's take a moment and talk about Bastion hosts. And this is a really interesting concept that many of you would have heard of, and some of you may not have, or you may have heard of them as being called jump boxes or management boxes, etc. This is a server or servers used for system management. And the goal here is to have this system management box to be very tightly controlled in terms of access. So the list of people who can access them are only those who require management access. Then upstream management of servers is only managed through this Bastion host. This means it's not possible to log into the other hosts and manage them when the Bastion host is not running. So in our example here, we can see that we have a number of sets of security groups. We have the ELB, the web, the app, and the Bastion security groups. Again, working from the left to the right, traffic hits our elastic load balancer, distributes load to our web tier. It's only allowed to receive traffic from the ELB on ports 80 and 443. It can then only pass information along port 8080 to the app server tier. The app server tier is only allowed to receive traffic from the web server security group. Then the database security group can receive traffic on port 3306 from the app server group, and that's the only place it can receive traffic from. Port 22 access, which is security group. so it would only accept traffic from there. The nice thing about this model is that when you are not doing management, you simply stop your Bastion host. It is basically impossible to hack a system that is not running. What about certifications? What about what Amazon does to protect the physical environment? Well, let's run through that. Firstly, we have a number of different certifications. I'll get into in a bit more detail, but these include SOC 1, ISO 27001, and PCI DSS Level 1. So these are audits and proof that we do certain things in certain ways. On the physical security standpoint, we have very much a nondescript data center policy. So essentially we have data centers in nondescript facilities. We don't publish the locations. We don't conduct tours of those locations. There is no need for people to know where or how they are. And so we physically control access very, very strictly. This means that access has to be audited and logged, and people can't just wander about the facility for no reason. And I can tell you from my own experience, I've spent many hours in very cold data centers around the place, and I have not been escorted on many occasions. Luckily, I'm an honest kind of guy, so I've had no nefarious thoughts in mind, but there was really no reason for me to be wandering around there all the time. On the hardware, software, and network side, there are a number of capabilities that take place. Firstly, we have systematic change management, the ability to audit and to roll back, of course, phased updates deployment, and also safe storage decommissioning. And this is very important for customers, because what this means is that before any hard disk leaves the Amazon facility, it is degaussed and shredded. This means that customer data cannot leave the facility unintentionally. We also provide advanced network protection. This includes protection against things like distributed denial of service attacks and other types of network attacks. So we're able to protect our customers using proprietary technology and also large capacity. It's often difficult to DDoS a website if it has more capacity than the engine that is driving the DDoS attack. Let's talk a little bit more about security standards. ISO 27001 is the standard most relevant to our region here in APAC. And we follow the ISO 27002 best practice guidance. And this covers our information security management system. The certification includes all regions, and we publish our certifying agent. For many customers, being able to deploy their infrastructure into an ISO 27001 compliant environment is a step up from their current security posture. Another nice thing is that PCI DSS Level 1 compliance is also available. So this is the credit card industry's certification protocol, and this is what is required if you want to create an application that processes credit card data. The nice thing is that there is no differentiation in terms of certification for the different EC2 instance types. All the way down from a micro instance all the way up to the biggest higher instance are all automatically PCI DSS Level 1 compliant. There's no special configuration to do, no additional charge. You can leverage the work of our qualified security assessor so that when you're designing your own application, you only have to worry about getting your application down to the hypervisor, authorized and certified, and then the QSA works with our QSA to certify the entire application stack. Again, this certification is in place in all regions. Speaking of regions, you get to choose where you locate your data. This is your choice. So reminding you again that AWS is broken up into a number of regions around the globe. You can see on our map here the different regions that are available to you. All of them, except for US GovCloud, are available to all our customers. Whenever you do an activity or perform an action on AWS, you choose which particular region you are acting upon. So if you are working with customers in the EU and you'd like to locate your data in the EU region, you simply direct that into the EU region. We will not copy, replicate, or otherwise move that data out of the region you have specified. In fact, the only way to move data between a region is to move it yourself. Now, we can help you with tools and approaches to that, but you would need to do the activity. It is not done automatically by AWS. This is really useful for a lot of customers, both in terms of bringing data closer to their end users, so servicing a global audience, and also being able to authoritatively say where their data is at any given time. And I'll take this opportunity to remind you that within those regions there are multiple availability zones, at least 2, often more. And these are independent failure zones that are physically separated, typically within about a metropolitan region within the specified region. So please do take advantage of those for your highly available and resilient applications. We also have a global network of edge locations. I think it's up to over 35 locations now. And this is used to both deliver content to end users with much lower latency. So, for example, we have an edge location in Sydney, which gives great performance to local customers, and also supports our global DNS infrastructure, which is called Route 53. So again, this edge location architecture is all about improving end user experience. Now, I talk a lot about the shared responsibility model. So what happens on the customer side? What are the things that you need to think about to make sure that your application is well prepared for deployment into the cloud and is secure? So we need to be ensuring good security practice. And the nice thing about the move to the cloud is that the rules don't change. You still need to be taking the correct mitigation steps you'd be taking today. So let's take the first one. If you have sensitive data, it should be encrypted both in flight and at rest. So this means that when the data is traversing the network and when the data is at rest on the hard disk or some storage device, it should be encrypted. You should already be doing this with your sensitive data. This should not be news to anyone. Now, you can use Secure Sockets Layer for all your AWS API calls, and this is the default that all of these software development kits use, so you don't have to do it yourself, it automatically happens. But you should also be doing it with your own application communication. Now, we make this a bit easier because you can use SSL termination with the Elastic Load Balancer to terminate your certificates at the ELB layer, and then you can also do ciphering and back-end server authentication from the Elastic Load Balancer to your web tier. So you can secure that data ingress and egress and also ensure that the servers that are receiving the traffic are the ones that are supposed to be receiving that traffic. If you're a user of S3, which is our simple storage service, which is large-scale object storage in the cloud, you can use server-side encryption. It's free and it's easy. You simply choose that attribute on the particular object and the data will be encrypted at rest. If you choose to, you can also implement any type of client-side encryption you would like before sending the data up to S3. So again, you have the option, you have the approach of how you wish to treat your data, how you wish to encrypt your data. There are also operating system level encryption tools available, tools like TrueCrypt, BitLocker, etc., and third-party products that you can use. Again, this comes down to categorizing what your data is. A lot of data is useful, but is not particularly sensitive. Naturally, things like credit card information, customer addresses, etc., are sensitive and must be encrypted. They should be encrypted on your laptop, on your backup tapes, on your on-premise infrastructure, in your broom closet, and in the cloud. It makes no difference. Similarly, you should be operating host-based intrusion detection systems and intrusion prevention systems. And you should be regularly auditing and monitoring your environment. So just because we have this great capability of security groups, you should certainly be using them, but we also encourage our customers to use operating system level firewalls as well. Why? Because this gives you additional level of control and additional level of monitoring and management. Again, it's this defense in depth model. You can have different groups maintaining those firewalls, you can have different monitoring of those firewalls, you may have a particular firewall that you like on a particular operating system. You can continue to use that today like you would in your own internal environment. You should be logging information all the time, and you should be logging to a separate centralized location. It should typically be in another location to where you're operating in. A very popular location is S3. So we have a lot of customers who audit and log to S3, either in the same region or typically in a different region. And we even have customers who will take their on-premises logs and be logging them out to Amazon Web Services onto S3 because they figure if they're compromised internally, they'll be less likely to be compromised externally. Now, in terms of the IDS, IPS type solutions, there are a number of partner solutions available, and you can check them out on our partner website. But vendors include Trend Micro, Symantec, and Checkpoint. Many of these will be very familiar to you, and you may already know what they are. Now, when you would deploy them on your operating system in the way you do it today. And this is important because you can extend your current management and logging tools to the AWS environment. And this is made particularly easy by using the virtual private cloud. Because in VPC, the addresses are assigned private addressing that you control, the ranges that you like, and are maintained for the lifetime of the instance, they work seamlessly with existing management tools. Again, the VPC is simply an extension of your existing environment. It's also very important to keep operating systems and application libraries patched and up to date. When you take an Amazon machine image and use that from Amazon, we will always provide you with the latest up-to-date patched version. However, we will not be automatically patching and updating the EC2 instances you have. So you need to make sure that you are patching those environments appropriately. One of the key reasons why you need to look after your own environment is because certain patches may conflict with other applications you're running. So you need to have some sort of governance and control about when you patch and how you patch. And you would use automated package services like Yum, WSUS for Windows, Yast for SUSE, etc. The nice thing is a lot of those repositories are located or cached, if you like, in the various AWS regions. So you'll find you get those patches deployed so much quicker on the AWS environment than you would on an on-premise environment. As well as focusing on the operating system level, it's very important to focus on the application level, the various languages you have installed, and the software development kits. They need to be kept up to date because it's typically that layer that has a very high attack vector as against someone physically getting access to your server. The nice thing about deploying into the cloud is you can easily do rolling updates. So, for example, you can have an existing server farm, let's say it's running 4 web servers connected to an elastic load balancer. You can create and patch a whole set of new Amazon machine images and configure those to attach themselves as part of an autoscaling group to that load balancer. You then terminate the, if you like, old machines and have the new fleet running with all the new patches without affecting any outage time for the end customer. It also gives you a very effective rollback plan in the event that something went wrong. This approach is also really effective if you do have a security compromise, because it makes it very easy for you to quarantine and take away those compromised instances, create new ones that are patched and appropriately secured, and then perform forensic analysis in a safe manner on those existing instances, rather than having to try and retrofit some sort of fix onto a physical machine. It's also important to note that if you're using the Relational Database Service, RDS, which provides hosted database for MySQL, SQL Server, and Oracle, it includes the option of automated patch application as well. So this means you can specify a time frame in which you'd like your patching to take place, and the system will be patched automatically for you. So again, taking away some of that heavy lifting for you. It's also critical to design your application to protect against layer 7 attacks. So these are things like SQL injection attacks, etc. And this is all about designing security into your application from the start. You need to think about how data is being sent into your application. Is it being validated? Is it being correctly formatted? Many exploits take place simply because it is possible to enter system type data or SQL type data into an input field and have it processed inadvertently by the application server. And then it burps out a whole lot of data that shouldn't be exposed. You should also be performing some form of API authorization and authentication for API-based applications. You don't want anyone just to be able to hit your endpoint API, let alone flood it with arbitrary requests. If you want to see a good example of security at the API level for a RESTful interface, have a look at the S3 API documentation for a great treatment of how we take care of that. There are, of course, a number of partner-based solutions to help against Layer 7 attacks. These include Layer 7 Tech, SafeNet, AI Cache, Encapsula, etc. Again, these are things you would probably have in place today. They simply extend into the cloud. You also need to actively manage your AWS environment and use the capabilities that are available to you. You should be performing regular security and architecture reviews. You should be rotating keys and credentials. You should be protecting those keys appropriately so that only those people who need them have access to them. You can also use the AWS Trusted Advisor security checks. These are available to you if you are a business level support holder. And these are automated tests that take place to look at whether you have ports that are open inadvertently or you're exposing traffic that should not be exposed to the internet. So a very powerful way to have insight into your environment. But again, it's really important to focus on what you're doing in your environment and actively manage it in a proactive way. And this ties into the fact that you need to test and retest your security posture. Security tends to be a moving target. One of the key types of tests that organizations like to do is called penetration testing. And this is where we check to see how secure our application is from external attack. Often we'll engage some sort of third-party white hat type hacking organization, and they'll try and crack into our applications, see if they can get access, see if they can find vulnerabilities, etc. Now, I want to make you aware that this type of activity against AWS resources is, of course, against the terms of service because we don't want people to hack us and we don't want to make that possible. What we do provide is the ability to obtain authorization first. And here you can see a bit of a screenshot of the contact form that we use, where you simply apply for a testing permission. You get that for a particular point in time, and you can use that how you like. There are also partners that provide this service both on and from AWS. What do I mean by that? So there are partners that will do proper testing for you and will allow you to and have a standing authorization from AWS to test AWS assets because we've vetted them. We also have partners who will do testing from AWS. So you may have on-premise resource that you want to check whether it is protected or not. You can use AWS as a launching point to run those tests as well. We have a lot of customers who do that on a regular basis. Again, a link to this particular page is down the bottom, aws.amazon.com/security. Now, often with security there are a lot of in-depth questions that need to be asked. And what we find is that if people access these particular white papers, they'll answer about 95% of the questions we get. So we have two key white papers that I want to draw your attention to and a new section of a white paper. The first one is the risk and compliance paper. And this takes a high-level view of risk and risk mitigation, what mitigations are available to you within AWS, and how you would answer typical risk and compliance style questions. The AWS security processes paper is a more detailed view of how we run a security operation. How do we manage staff? How do we destroy data? How do we manage access to systems? How is the hypervisor secured? Etc., etc. Lots of questions that people would have. It's about a 30-odd page document from memory, and it makes interesting bedtime reading. And we've just added to that bedtime reading with an appendix. This appendix contains the answers to the Cloud Security Alliance Consensus Assessments Initiative questionnaire. This is a questionnaire put together by a third-party organisation that is designed to try and create an even playing field, if you like, of understanding around the security posture of different cloud providers. We've gone through and answered all of those questions, and there are a large number of them, in detail so that you can see how our security posture looks compared to other organisations. Again, all this resource and more, including frequently asked questions and questions around the various certifications and the ability to request those certifications, are available at the microsite aws.amazon.com/security. Now, for Australian and New Zealand users and customers, I'd like to point out a couple of things. Firstly, please do save the date, November 13th. We'll be having our first AWS Customer Appreciation Day. You can see the Twitter hashtag there as well. It will be located in Sydney, and we'd love to see you there if at all possible. We also have released a brand new resource centre that is the jumping off point for all the resources in ANZ that are relevant to you at aws.amazon.com/apac/arc-anz. And of course, if you want to keep up to date with AWS information, can I encourage you to listen to the AWS podcast? My good colleague Simone Brunozzi and I put this together. Typically it comes out on a weekly basis, and it's available to you at aws.amazon.com/podcast, and it'd be great to have you listening to that. So now I'm going to start running through some questions. There's a big long list, so please enter them in the question area of the console, and I'll cover as many of them as we can. So let me just flip through here and get to see how many questions we have. So one question we have is, do the charges around using VPC and VPN vary depending on your security configuration used? So to clarify, VPC does not cost anything. The use of security groups does not cost anything. The only thing that is charged for is if you choose to use a hardware VPN, it's 5 cents per hour for the connection. It works out to be about $500 a year. So it's not a big cost, but that's the cost that's involved there. Looking at some more questions here. Quite a few questions asking around whether there'll be a region in Australia. We have a long-standing policy that we don't talk about future plans. We do like to listen to customer feedback, so the more of you that say that you'd like a local region, we certainly do pass that information back. So thank you for asking. There's a question here just to clarify the difference between a normal instance and a dedicated instance. So in a normal instance, you get an instance that is hard partitioned. You get your own area of RAM, your own area of CPU, your own area of storage. However, the physical host upon which that instance resides may be shared with other customers. So you may be on a particular host and then another customer for another part of the world may be on the same host. You can't see one another's data. It's completely partitioned. There is no ballooning of resource, etc. However, you're sharing a common physical host. A dedicated instance says that you will never share a common physical host with any other customer except yourself. So if you have multiple instances, they may reside on the same physical host, but you will be the only customer on that host. Another question, how can I reduce the latency to access AWS from Australia and Sydney in particular? So there's a number of answers to that question. Firstly, if you're talking about static type data or cache type data, so this could be images or PDF files, etc., then using our CloudFront content distribution network will solve your problem. Essentially, we have an edge location located in Sydney that gives you very fast response time for all types of static data. We have a number of customers using that. A notable example is styletread.com.au, and they have a shoe sale site, lots of pictures on there. Jump on there, have a look, you'll get to see how it performs. For other types of use, we have a lot of partner solutions, so people use tools from Riverbed or other types of solutions to provide that WAN optimization across the line. However, before looking at optimization, it's important to test what you're actually doing. In many cases, the performance is totally adequate. And in fact, I'd say in your day-to-day activities, you're probably using a lot of websites that are hosted on AWS and you wouldn't even know it. Another question about using firewall and antivirus, how partner solutions are integrated. So it is the same installation as you would do in an on-premise environment. You would need to install your agents. So those agents can be installed and baked into an Amazon machine image of your own making. So you can take one of our base images and install, for example, you can have that operate as it normally would for every single instance that's spun out from that Amazon machine image. Another question here, how long does it take to turn around a penetration testing authorization request? From memory, it's a couple of days. The SLA is in the document. It doesn't take long as you provided sufficient information that we have. So we need to have that information. A follow-up question is, does the AWS customer need to complete that authorization request or the testing organization? So again, it would need to be the AWS customer themselves who fills in that request unless you're using a testing provider who already has authorization from AWS. We can help you out with that. Just going through the list here. So question, can non-VPC EC2 instances change security group attributes after creation? So when you launch a classic EC2 instance, so one that's not in VPC, you are able to assign the security groups it belongs to at start time. Once it's assigned, it maintains those security groups for the life of the instance. You can change which ports are configured for the security group dynamically, irrespective of the lifetime of the instance, but you cannot change which security group that instance belongs to. If you wanted to make that change, you would need to terminate the instance and start a new one. In VPC, you can change them dynamically. At the moment, that is staying the same, so that doesn't change. Just looking at some other questions here, sorry, just as I'm flicking through. So a question here about data transfer. When an external application calls an API S3 to transfer data to an EC2 instance, does the transfer happen directly between S3 and EC2? Really, this comes down to how you want to configure your environment. If you're having the traffic being called from an EC2 instance to S3, then that's how the traffic will traverse. It will traverse across the SSL link directly to the EC2 instance. If you choose to have it go directly to a client, maybe a web browser, etc., it can go directly from S3 to the web browser over SSL as well. So you get to choose how it gets distributed. Another question here about inbuilt protection against intrusion and what explicit defense do AWS provide against DDoS attacks? Are there any practices users can implement to also mitigate against DDoS attacks? So firstly, at the network layer, we do not allow the use of promiscuous port mode, port sniffing, ARP snooping, poisoned ARPs, etc. So anything, if you like, nefarious at the network layer is blocked by default. So we don't allow that to take place. Multicast is also not allowed to take place because that's an often used attack vector. So on the network layer, we have complete control over that network and stop any incorrect activities taking place. Denial of service attacks are typically, though, more focused from external sources. As I mentioned at the start, one of the best ways to avoid a denial of service attack is to have more resource than the attacker. Fortunately, in an elastic environment like AWS, you can throw as much resources as you like to overcome a particular attack. However, we do also work collaboratively with our customers. If you are finding that you are experiencing a distributed denial of service attack, you can log a support call with us and we will work with you to identify which IPs those attacks are coming from and cut that traffic off for you. So we work very closely with you to that. We also have our own proactive tools that we run to identify potential attacks as well, but we will not turn traffic off because, as you can imagine, a distributed denial of service attack looks exactly like a really popular website, so it can be very difficult to distinguish between the two. Another question here, what is the best practice of securely connecting a VPC in one AWS region to a VPC in another AWS region? Great question, and one that we get asked often, and certainly we're working on some interesting solutions in that area. Certainly at the moment what customers will do is they'll use a tool like OpenVPN or OpenSwan. They'll set up an instance running in each VPC and establish a VPN tunnel between those two VPCs. So they essentially peer those two VPCs using EC2 instances running some sort of open source VPN tool. Does AWS have a way to screen AMIs being available for users to create instances with? So like an App Store screening process. And how can you have confidence that in choosing a reliable and verified AMI? So this is where there are a few answers to this question. So firstly, when you choose an Amazon machine image, you'll see that the owner of that image is published, and one of the owners is, of course, Amazon. So if you're choosing an Amazon machine image, you know where it came from, you know that we stand by it. Obviously, lots of people want to create lots of machine images and share them with the world and potentially sell them as well. And so what we've done is created the AMI Marketplace. The Marketplace provides an interactive environment where you can see what software has been created, who has created it, where it came from, how much they're charging for it, and what the support will be as well. It also allows customers to comment on the use of that software and give it approval. So things just don't magically appear in the Marketplace. They need to be certified and validated, but they adhere to certain standards as well. That said, as with all things in security, you don't trust anyone. You should still do your own due diligence around checking things like what certificates are on the machines, what software is running, which processes are running, the various hardening that you would do, etc. Another question here is, if my company would like to sign up for AWS, will there be a consultant assigned to guide us on how we can leverage AWS and what will be the charges? So one of the beauties of AWS is it is all self-service. So you can do as much as you like on your own. But we know that many customers would like some assistance, would like some expertise as they're going through the process. Globally, we have a number of pre-sales engineers who are available as solution architects who will come in and help you understand both how to use the platform, how it works, where the advantages can be. We're happy to engage with you on a proactive basis in that, and there is no charge for this service. So we're very happy to onboard customers in a way that makes them feel the most comfortable. We have many customers who have never spoken to us and deploy massive environments. We have other customers with whom we meet every week. It's totally up to you. Another question is, what would be the best practice to establish file transfer between EC2 instances within the same location? Again, best practice would be, as it is today, using tools like Secure Copy, SCP, or other types of encrypted pipeline tools make the most sense. The fundamentals don't change. The fact of the matter is that you have way more resource available to you, though, when you're using AWS. Just go through and get a few more questions here now. I think we're covered. Excellent. So I'm just going to wrap up again. So just a reminder that good security, whoops, we've lost that window. Let me get it back for you. Don't need those numbers. Good security practice really starts with you. We have a shared responsibility model that allows you to control where your data resides, how it is residing, how the application is architected, and how the solution is delivered. You can have great confidence that AWS is working very hard to certify, secure, and manage the underlying infrastructure. And you can share that with your own stakeholders with confidence and with great certainty. And we're always happy to work with you to talk to your own stakeholders and to help you architect your application in the most secure and appropriate fashion. So I'd like to thank you for your attendance today. If we haven't got your question, we will email you an answer, but I thank you for your attendance and wish you all the best for the rest of your day.